FWM202. Hopefully you're here to learn about Device Farm today. If you are not, then you're probably in the wrong session or saw the wrong room. So just make sure you evaluate, make sure you're in the right session. But without further ado, I'll go ahead and introduce myself real quick. My name is Sam Patzer, and I'm a solution architect covering Riot Games. So my customer's pretty awesome. So I'm going to let them talk and introduce themselves. And then, yeah.
Hi, I'm Alex Lachowski. I'm a staff software engineer at Riot Games. I work at the central tech facility, building centralized tech solutions for all of the games in Riot Games. And I'll hand it off to Nikhil.
Hey everyone, good morning. My name is Nikhil. I'm the principal cloud engineer for front-end web and mobile. More specifically, I look at Device Farm in a specialized role and have been with the team since the launch of the service. I enjoy making customers navigate their challenges, technical, product, commercials, anything that serves towards improving the quality of their apps. Happy to be here, and I'll hand it back to Sam.
Awesome. Thank you, everyone. So first, I'm just going to go over a quick agenda for the presentation today, so that way you know when to pay attention, when to fall asleep, definitely like during my time. So first of all, I'm just going to give a level set. This is a 200-level conversation/presentation, so just want to make sure everyone knows what Device Farm is and why would you care about using something like Device Farm. After that, I'm going to kind of talk about who Riot Games is and where do they get their start and what are they doing today. And then afterwards, I'm going to hand it off to Alex to talk a lot more about kind of what does Riot do when it considers testing as a whole at Riot, and then dive into more details around what they're doing with Device Farm and how they implement it at Riot Games. And specifically, how do they test games? And then afterwards, they're going to kind of talk about the decision-making behind why they choose Device Farm and some common questions that they get when they talk to their engineers about Device Farm, because the game teams obviously don't run the Device Farm. And then afterwards, I'm going to hand it off to Nikhil to talk about some of the new features and recent launches that Device Farm has had, because there's a lot of cool new things that were coming out today. So, to level set, what is Device Farm? Device Farm is a DevOps tool that allows you to test, validate, and debug both mobile and web apps. There is no provisioning needed, and it's just a one-click button, and you get to take advantage of the cloud, where it scales out to the needs that you need, all in parallel, so you can run multiple tests at the same exact time. What this does is it enables your teams to be able to test across hundreds of real devices. Let me make that clear, real devices. So these are real devices in the cloud, across thousands of versions that you're able to run these tests on. So what's really nice about this is it allows you to, for example, when iOS releases another minor version or major version, you're able to continue to test on previous versions as you see fit. Most enterprise customers nowadays support anywhere between 3 to 4 major versions back. So what that means is that if we're on iOS, 19 or 18, I lose track at some point, you have to continue to support backwards as well. So you have to go iOS 18, 17 as well, and then on top of that, you have to make sure all your features work. It all sounds great when at WWDC for iOS or Android's Google Next project, they announce some new features that are enabled. Well, obviously, you need to make sure that you have backwards compatibility. And a lot of times, that means that you have to make certain actions available on older iOS versions and make sure those actions are still actionable on those older iOS versions. And to have a device or multiple devices that are running all those different minor and major versions, it actually can be a big headache. Because what happens if one developer clicks the update button by accident? Next thing you know, you lose that device on that version, and maybe that's the only device on that version you have. So there's a lot of different considerations. What's nice about this service is that it just manages all that for you. So all you have to do is just install the app, and then you run the app with your tests, and then it cleans up the device on your behalf. And what it does enable you to do is no updates. So you're actually able to continue to test on those versions in the previous. Also, you can automate all your tests as well. So for those that have ever built a mobile app or a front-end web app before, you know the pain of opening up Firefox and opening up Chrome and opening up Internet Explorer to make sure that the animation isn't broken or the CSS looks horrible, all that sort of thing. Or same thing with mobile apps. Want to make sure that it looks good on a tablet, make sure it looks good on the phone that's massive, the phone that's small, make sure it fits with the bezel and everything else like that. That all can be done automatically now, rather than you having to plug in every single device, open every web browser, and test every animation. If you can automate that, that is what Device Farm is enabling you to do. With all this, you also get all the logs back as an artifact. What does that mean? Is that you're able to then automate and be able to take a look at those logs and actually debug or send that information back to the engineering teams, so that you can enable your engineering teams to continue to iterate or even debug and go down the depth as well. one of the big things we always are asked about is like, what happens if, for example, we're all familiar with Android devices. There's about 5 million different flavors of Android. We have Samsung flavor, Google flavor, every single different type of flavor. And all those introduce their own bugs or own issues. So for example, sometimes Samsung releases their own version update for Android. That might introduce a bug that you might have to go solve later on. And you can actually go test that and debug it with remote access as well. So you actually can then dive into that one device, be able to actually test to see where that issue is coming from, get those logs down, send those to the engineers, or the engineers can be doing this themselves. Now, as far as why would anyone care about this? And the biggest thing is just around making sure that the quality of your app is continuing to exist throughout the entirety of your app. A great example is when iOS decided, or Apple decided to add a bezel to all their phones. Now, everyone saw that was like, wow, that's really cool as a user. But as a programmer, everyone knows that's a headache, because now you have to work around the bezel. Now, depending on the view that you're using with iOS, it might overlap with the bezel. All of a sudden, you're hiding your titles because of the bezel, and all these sorts of things that as a user, you don't think about, but as a programmer, it's a big headache. And you might not catch those because you might not have the newest phone, or there might be just a bunch of different issues that may arise. So that's where Device Farm comes in as well. Now, extrapolate that out to all the different devices and versions out there, you can see why something like Device Farm could be very, very helpful. And if I forgot to mention this all can be done in parallel. So what's super nice about this is that while you're running all these tests, they don't have to be plugged in individually. You can run it across hundreds of devices all at the exact same time, get back all the results at the same exact time, and then just collaborate and be able to ship off the errors, if any errors, to anything else, and you're good to go. Now, one of the other common questions we always get is that I don't have tests written, or I don't have a team to write tests yet today. I can't use Device Farm. Well, Device Farm does have built-in things like a built-in fuzzer. For those that aren't familiar with what a fuzzer is it pretty much just randomly clicks around on a screen, navigates randomly through your app, and just makes sure that things just don't break, which can be very helpful because other things that do happen, and something that Device Farm tells you is like what your CPU utilization is, what is your memory usage, and what is like your thread usage. You don't want a bunch of like navigating back and forth between your device menus, a bunch of threads to be spun up that aren't closed. You can have a device that overheats, a device or an app that crashes, and those things not always sometimes appear on a automated like desktop with Xcode or something like that, because Xcode does better thread management. You're also working on a device that has 10 times more memory than your iPhone does, so it can handle way more threads. So these are things that running on real devices actually can enable you to do better. So that is what Device Farm is. It's like a 10-minute spiel on Device Farm. So hopefully you guys understand what Device Farm is at a very high level, so that way when Nick Hill and Alex talk about it a little later on, you're not like, what is Device Farm again? That is what Device Farm is. So why should we care about who Riot Games is and who is Riot Games? So Riot Games, or I should say Riot Game at this point, was founded in 2006. They released their first game in 2009 called League of Legends. It was 2 teams of 5 battling to destroy the opposing team's base or nexus. With that, they decided that what would be awesome is to make this a competitive sport, and that was the release of LOL Esports. So LOL Esports became a global leader in esports with an annual League of Legends World Championship featuring the esports teams of 12 international leagues. It is one of the most popular and largest gaming sporting events in the world, with last year, or I guess this year's esports hitting over 6 million concurrent viewers. After that, Riot Games became Riot Games, adding an S in 2019 and releasing 4 new games. So on top of League of Legends, they also released Wild Rift, which is a mobile version of League of Legends. Some sort of kind of coming into where Device Farm starts to exist a little bit at Riot. And then on top of that, Teamfight Tactics as well, which is an auto battle chess game. That's where Device Farm really takes a shine. And then Legends of Runeterra, and then Valorant, which is a first-person shooter. Now, Riot is becoming more and more like a media entertainment company, where they're now releasing not only just games, but also other content as well. So they have a lot of different things like brand new comic books, as well as board games, Arcane, which is a fantastic Netflix series that I recommend go watch, as well as they now have their own independent studios that work with Riot's IP to release awesome games like The Legend of Nunu, which is a brand new game that just released this year. So without further ado, I'm going to hand it over to Riot to talk a lot more about what they do with Device Farm and all the awesome things that they do.
All right, thanks, Sam. So to start out, I'm going to give you all a Quinn's eye view of testing. And don't worry, if you don't know who Quinn is, it doesn't make sense even if you do. It's separated into two main categories, gameplay tests and functionality tests. When you think about testing a game, most people are going to think, is this fun? Are these characters fun to play? Does this mechanic work well with this mechanic? Is this level designed well? You think of things like play tests. All of those things fit into the gameplay test category. It's what humans do. It's how we know a game is good and fun to play. But there's an entirely different side of testing that I'm going to be calling functional testing that focuses on the technical side of things. Now, to dive in first, I'm going to go in with gameplay tests. So like I mentioned, it focuses on things like mechanics. Is the game fun? All of these things are great, and you need to focus on them in order to make sure you have a game that players can enjoy. Take us back to EVO of 2023 this year. We had the first gameplay demo of Project L. Tons of people tuned in, were able to play Project L, and we got a lot of good feedback. How great does it feel when Darius's axe swings down? How does it feel when the characters are introduced? The stylized graphics of the thing, these are all done by humans and tested rigorously by developers and QA alike, as well as playtesters such as yourselves. But now you know that you have a fun game. How do you know that it works on everything that it needs to work on? That's where functionality testing comes in. And functionality testing comes into things such as performance testing. Hey, this runs on this device, does it overheat? Like Sam was mentioning earlier, how many threads are allocated on this device versus your developer PC? You need to understand how your game is going to be run on all the plethora of devices that your customers are going to be using. And I'm going to tell you a quick story about a QA person who started out as, hey, we're a game team, and our game is fun to play. We know it's fun. The levels are all working. QA, can you make sure that it works on this device? And for the sake of this story, it's a mobile device, so it's an Android device. And they go, okay, here's I take my phone out of my pocket. QA, can you go test this? It's like, okay, well, this device was Android 10. And yes, the device works on Android 10, but now Android 11 is released. Okay, here, Mr. QA or Mrs. QA, I have another phone. Plug this into your device. Plug this into your computer and test it on this. And now the QA is going, okay, now I have to run these same tests on two devices. Now 3, Android 12 comes out, Android 13, Android 14, iOS comes out. iOS devices. There you can see this QA's desk is stacking up with tons of devices, tons of cables sticking out, and this poor QA can't manage it, so they hire another QA. And so parallelism and scaling was thought of as a human-solved problem. It was people coming in and running your tests on different devices, and if you needed more, you just hired more people and you had more phones, and this became a distributed problem across all of Riot. So time to rewind about how did this happen at Riot. Once we put the S in Riot Games, testing became a big problem on a functional level. We needed to be able to test on all of these devices, and this QA's story was not isolated. Every single game team had the same process. You acquire a physical device, luckily not out of a developer's pocket anymore. We go through official processes, but then you still set it up on somebody's desk, whether it's a QA or a developer's desk. You plug in that device, and then you connect to a separate test branch, and then you have to investigate those issues. And this is just not scalable, as each and every game team had their own way of doing this. So how do we solve this? Well, we advanced to a centralized solution. So this is where the central tech comes into play. Everybody agreed that the more game teams we have, we need to advance to a more centralized solution so that these people aren't acquiring devices and piling them up on some poor QA's desk. So we designed a high-level service that takes API requests from teams, pipes them through some sort of queue, allocates them the necessary devices for their testing, and then puts them into, and then puts all of the results into some sort of artifact store that they can then consume. Now, what types of things are these testing? So there are multiple things, and now I will dive in a little bit deeper into how exactly we did this at Riot. Now, I've got a laser pointer. I apologize, I only have one. So as I was mentioning in the previous slide, we have a centralized solution for all of our game's testing. But how do we make sure that each game team has the ability to test using this centralized service? The first thing is we make sure that we have an API ingress point. For this, we used API Gateway. It works. Every single team can utilize this, whether it's in an automated CI/CD, continuous integration, continuous deployment pipeline, or if it's an individual QA person, or if it's some developer testing on their machine and they don't want to connect their phone to their device. They can now call the API endpoint. This then gets routed to a workflow request Lambda. And this Lambda, what its purpose is to take all of the requests from these game teams, from API requests, and put them into a queue so that we can prioritize which requests are done first. And this queue interacts with multiple Dynamo database tables, in order to make sure that the teams get the correct devices and that the devices are ready and in a prepared and clean state for when they're ready to be used. And I'll touch on this. So there's two major underlying device farms underneath this service. There's the on-premises devices, which is where we gathered all of the devices that were used to be piled up on the QA's desk into the developer's desk, and we centralized those into an on-premises managed by Riot Device Farm. The other major aspect is the cloud-based device farms, or AWS Device Farm. And we really like to use the cloud-based device farms for multiple reasons. When you have physical devices and you're managing physical devices, it becomes a really scalable or unscalable solution because you have to manage every single device manually. Let's say that a device overheats, device breaks, hardware failure, someone trips on a cord. All of those things, you have to now go in, you have to have somebody manage, make sure that the device is back up and running, and get that back up and running so that the teams can test on their game. Whereas if you use a cloud-based solution like AWS Device Farm, all of that is managed for you, so you don't have to worry about that. And so that's where these requests get routed, is you have this workflow decider lambda. So this workflow decider lambda will take your request from the queue, and it will then decide, hey, you've requested these devices we have available on premises, or these devices we have available in the cloud. And then it will make sure that all of those devices are in a clean and proper and ready state, and then it will kick it off. And that's where this mobile state machine is. And I'll dive into that later on the next slide, don't worry. And once those tests are running on those devices, all those metrics and analytics are being gathered on those devices, we then post events based on every single thing that's happening. So it's like, hey, your device is currently running the test. Your device is done running the test. Your device is gathering artifacts, things like that. All of these are piped through the Amazon Event Bridge, which are then picked up by the workflow update lambda, which then populate things such as the Kafka stream and the workflow request table. So if a workflow request goes from in queue to executing, that lambda is responsible for that, as well as, hey, your test is done or your test has an update. We post those real-time events on the Kafka stream. So in the next slide, I will mention why is AWS Device Farm the most secure and best farm for us to use during this process. Because it seems counterintuitive at first. As a game team, you're giving up a lot of control. How do I make sure that my game is actually running at like a good pace? How does it run my game? Is this even secure? Can it contact things like my internal game servers? All of these are questions that people ask us when they come to our team. And we say, hey, come use our cloud farm. They go, great, you have devices, but how does this work? And when we tell them that we have things like device logs, screenshots, metrics, and video, they start to go, okay, so now I can actually see the results of my test. But how is this actually running my game? So the way that the games are run is the game teams themselves do have to break down and create a custom functional testing build. And what this means is that there is a separate chunk of code, for lack of a better term, where they actually have to write these tests and create a testable version of their game that is then invocable through some sort of medium. And in this scenario, Appium is the medium. And Appium is a generic framework that allows you to run on both iOS and Android. And it has very great native support. But how we do this at games is the games have a separate testable branch, and then Appium then invokes that branch with certain parameters, like, hey, I want to run my game running this map and this character, in those types of scenarios. And what this allows us to do is, at scale, we can run these tests in parallel across dozens of devices. Whereas this poor QA was pressing the same button on 5 different phones, now we can do the same thing on 50 phones. And we can do it at scale with no issues. The next major thing is, okay, so you can run my tests. I have to have a functional test, but that's okay. You get some device logs and metrics. How do I know which devices I can run on? And this is where the centralized device farm controller comes into play, is we had a queryable database that says, here are all of the devices that you can run. Here's all of the makes and models, and here's all of their availability and their metrics and their specs. And here's what you can select. And AWS Device Farm allows a filterable service that also allows us to do those same things. So all of those options that we offer to our game developers is pushed all the way down, whether it's on-premises or in the cloud. It's all possible there. And the last thing that game teams really want to make sure is, can this connect to my game server? How does this actually work when I need to test something internal that's not public? And that's where VPC support comes in. With VPC support, you can actually connect your entire mobile testing network in the cloud or on premises to your VPC. Now, on premises is obvious. It's like, hey, we have these. We just plug them into our network. That's great. But how does this actually work for the cloud? So for this, we have the device farm networking layout. So for simplicity, I'm just going to say there's the Riot AWS account, which is in the device farm, which is where the device farm controller lives. That entirely serverless service that I pointed you guys through earlier. And then depending on how you route, we have on-premises solutions, and then we have the cloud solutions. And all of the AWS Device Farm devices are in separate AWS account. And through a VPC configuration, during the call to the AWS Device Farm, we can say, during this test run, please connect to our VPC during your test run so that this device appears to be directly on our internal network. And this is all done safely and securely. And it makes sure that things like unreleased game servers, unreleased games can all be very easily tested on the cloud with no issues. And all of this culminates into game teams being able to do things like nightly tests, regression testing, scaling testing, load performance testing. All of these things are now possible, whereas before it was, hey, can we get QA to slot in a time slot for us to test our game? Now you just make an API call. And so to recap, here are the common questions that we get. Can it run my game? How does your framework run my game on the cloud? And for this, we had Appium. We can run your game through a command line. As long as your game accepts command line inputs, we're fine. How does it run my game? Well, it runs it through a service called Device Farm Controller that then routes all of your requests onto the device itself, whether it's on premises or in the cloud. And it runs your commands exactly as you'd like. Can it connect to my game servers? This we covered in the VPC section. A huge concern for a lot of game teams. You want to be able to connect to your internal things. We have an entire VPC configuration that's customizable and safely and secure, whether it's on premises or the cloud. What artifacts and metrics does it provide? Sam touched a little bit on this. It provides things like CPU metrics, load metrics, but through the power of Appium and AWS Device Farm support, it also does things like screenshots, videos, and log bundling. And all of these things can be separated based on configurations that the game teams provide. And finally, game teams, as usually is one of the last questions that they ask, is this secure? Hey, now that it actually runs my game, is this actually safe for me to run my game? And the answer is yes. It's all within the virtual private cloud that you set up in AWS. None of this is ever going to the WAN. It is all internal, so everything is very, very secure. And then even after security, can it scale? Now that they know that it runs my game and it can run it securely, how does this run at scale? This is, I think, where the big benefit of functionality testing comes in and where things like Device Farm help immensely. You don't want to be scaling up your physical on-premises device farm. Everybody knows it's a pain, it's expensive. Cloud lets you do it by just sending an email. Hey, can we access these 20 more devices? Hey, we want to access 50 more devices on our private cloud. And with that, I will hand it off to Nikhil to go more in depth about the future of AWS Device Farm.
Thank you, sir. All right. Thank you, Alex. It's been a wonderful journey working with Riot, with your talented team, and just seeing what they have come up with. And I'm looking forward to the things that we feel in the future. Before I just jump into new features and saying, here's what it is new, here's how you do this, let's take a step back. The title of this session is Improve the Quality of Your Apps. And while Sam and Alex did touch on a lot of, like how do you approach this, how do you think, what are the different aspects? If you say, I want to improve the quality of my app, is it just go out, test on multiple devices, and it's done? Is that what it is? For most customers, that's how they start. Well, I got to test it on multiple things. I have several frameworks that need to be invoked. But end of the day, if you're not testing on multiple devices, all those other questions become less relevant at the start. So one would ask, well, okay, how do I go about this? Am I just starting off with manual testing? Am I doing full-blown automated testing? What is the baby step here? So in that view, one could take an approach saying, well, let's start with the approach that Alex's team took in his rewind slide where they said, everyone go out, buy a device, good, great, we're doing great. Oh, new release came out. Oh, there's a new Pixel. Oh, there's a new Samsung. And things start to get a little unmanageable at that stage. So what is the other approach? Well, most folks want to reach a mature model saying, here's an end-to-end flow where you are doing something and the entire pipeline works and you know what has changed. It could be between versions of an app. It could be just a single line of code. It could be just a splash screen that you changed. So most people in this room will agree that it is an end-to-end mature model that they want to go to. On top of it, you want to have it secure and you want to have it fast. But in all of these details, there is a simple, when you talk to other customers, when you just talk to people, it just comes down to plain 3 English sentences. When they say, can I do this somewhere? Can I do this on my own? Can I do this on AWS? And those simple 3 things are, let me connect to my private endpoint. It could be anything. It could be public. It could be private. It could be a mix. It could be an on-premise. So that's like, let me connect. I have databases or whatever it may be. Second is, let me run it from anywhere. I have a local machine. I want to reproduce something. I have a CI/CD system. I have this legacy system that's there. So that's number 2. Let me run it from anywhere. And then number 3 is, let me customize it. Sure, it runs. Sure, I can connect. I want to make some changes to it, right? So let me connect, let me change it, and let me run it from anywhere, right? And one approach which most folks take is there's hyper-focus on let's just get one stuff running, and then we'll figure out along the way, which is not a wrong approach at all. But I think these three can work in parallel, independent of each other. So let's work on each one of these pillars and just say, firstly, our point was, let me connect to my endpoints. So Device Farm has a VPC ANI feature that Riot Games has used. And this gives you an ability to securely connect to any private endpoint. This could be on-premise, it could be on an AWS VPC, or it could be on another vendor. So using the VPC ANI solution, we can put not only your devices, not only you can put an iPhone and a Pixel in VPC, you can also put the test host or the host machine to which the device is connected inside the VPC. So when you're running a test, either manual or automated, you connect the device to the host machine, you run some commands. But at times, you may want both of them on the same VPC. You may even want both of them on the same subnet. So this is what that feature enables. Furthermore, when you're running an app on a device, it may be a game app, it could be a streaming app, it could be a messaging app. It may have different traffic types. It could be WebSockets, you're chatting, it could be streaming something. The connectivity feature will support all traffic types. There's no restriction on those. And this feature today exclusively works with private devices. So on Device Farm device offering, we have two types of offerings. One is public devices, which are shared devices. Someone saying, hey, I need an iPhone 13 running iOS 17 or iOS 16. They can go in and find that device. When they are done, device farms make sure that they clean all the artifacts, including app, test, any logs, any screenshots, anything that you may have produced, not only on the device, but also on the host machine. So once those are done, any other person who's waiting in queue will get the device. Now, there are multiple instances of each one of these devices behind the scenes. It's not just one instance. So if you get one, we'll have multiple of those. And private devices, in contrast, are dedicated devices. You don't want the guesswork. You want your dedicated capacity. You may also have features such as, hey, I need to install MDM profiles. I need VPN on my device. I might have developer certificates that are exclusive to this. I might have SSL certificates that connect to my private endpoints. Private devices will enable those features. And so VPC works really well with private devices today. So we got the let me connect to my private endpoint. Now let's say, let me run it from anywhere. So for let me run it from anywhere, going back, Device Farm today can be consumed via multiple starting points. One is, the most friendly one is your AWS console. You go to the console, access Device Farm. The other is your AWS command line interface, your CLI, and then multiple AWS SDKs available in multiple languages. So that's one point of consumption. And then there is a rich ecosystem of plugins that we have developed. For example, there's Jenkins plugins, there are Gradle plugins that you can go to those official stores, such as Jenkins App Store, and then you can just download it from there, the plugin store. Building on top of that, we now have GitHub Actions, which was newly released just a few weeks back. And so this will give you the ability to invoke a device farm in an action directly from your GitHub repo. And that's not the only thing. You would also want features such as, hey, I ran my test. Now I'm looking at the results. I want to automatically cut issues, assign it to folks. So the GitHub, the Device Farm GitHub action will also support that. You can automatically create issues. Say, hey, test number X failed. Here's the issue. That's automatically created for it. And then these can be scheduled as any GitHub action. These can be done on when you're pushing a code, when you have a new pull request, or it could be even invoked on a schedule. Nightly build, for example, run this GitHub action. So we got the let me connect to anything, let me run it from anywhere. Now the third one is let me customize it. So when you schedule a test on Device Farm, now those of you in the room who may have heard about this for the first time or have never used it, and we don't really have a demo, which I'll come to, but I'll give you a high-level 10,000 feet primer. Essentially, when you're saying, I want to test something on Device Farm, the system setup that you need is really just two inputs. That's all. You just need your app that you need to be testing. It could be a native app, hybrid app, or it could be a pure web app. So that's input number one. Input number two is your tests This could be, you could take the source code, you could take the build output, or you could just say, hey, pull my test on the fly from somewhere, pull it from a repo. So that's your input number 2. When you give these 2 inputs to Device Farm goes out and pulls these artifacts, spins up a EC2 host machine on the fly for your Android test, and a Mac machine for your iOS test. And then behind the scenes, it will connect those 2, download your artifacts on those host machine, form a connection with the devices you selected. So even if you selected hundreds of devices, it will spin up hundreds of hosts for every single device. There's a dedicated host. Even in your same session, no host is being shared with any other device. And so there's a one-on-one mapping between the host and the device on the fly. Now, when we launched the service about close to 8 years ago, we had an Ubuntu-based EC2 instance. And obviously, we have upgraded it. Security is prime. But as time passed, we realized customers have more software dependencies. They're using more third-party libraries. They're using tooling that's not as restricted as it used to be. For example, Alex's example of using Appium, but then they have their own gameplay testing and their own framework. So things become involved. So the short version there is you need more control, and you need to be able to install software dependencies faster and more easier. And so we now have a new Android test host. And this essentially is an upgraded hardware, runs Amazon Linux 2. And the inherent benefits of doing that is we have observed, on an average for the customers so far, a 32% improvement with the overall test execution time, so your end-to-end execution times. And that is a factor of us also putting in more dependencies on these hosts, which we realize customers use. For example, customers might be just migrating to Python 3.10. As an example, don't hold me, anyone in the room who's really good with Python. But I see customers often say, hey, I want 3.6, 3.7, 3.10, 3.11. I have one test branch that runs on this, but the other test branch runs on that. So to manage all of those dependencies, the host already comes pre-installed with dependencies that most of the popular test frameworks might need. But you can now simply use a Device Farm CLI centralized toolchain, the one that's highlighted. And if you look at that screenshot in the example, it's as simple as saying on line 22, Device Farm CLI use node, whatever version, 16 or 18. And what that will do is not only update the node version for you, but it will also update all of the underlying dependent packages that go with node that your test might need. So it's even reducing further the lift that you need. Because Device Farm's design principle has always been don't fight the ecosystem. What that essentially means is if you are running and writing a test a certain way on your local machine, we do not want to fight that. In fact, we want to enable you to run it as is, more of a lift and shift. So in order to even further accelerate that, we are taking away the boilerplate work which says, oh, I got to change my Python version. Wait, I also need to go pip along with it. Oh, wait, I need to also change my Python environment with it. So all of those things are taken care by that Device Farm CLI toolchain. And as also a other benefit is now we have faster manual testing. And what that means is Device Farm, what Sam touched in the start, not only does it support automated testing, but you can also do manual testing. So manual testing traditionally has given a frame rate of anywhere between 8 to as much as 12. And while that has been okay, but imagine someone like Riot running it and saying, well, I want every frame. I don't want to lose a frame when my game is doing some fast-paced action. And so not only does the new host provide improved manual testing, but we also have an improved frame rate, 25 frames per second on all these devices. So you're not going to miss any frames when you're running these. And Appium being a pretty popular testing framework, cannot go to a test framework talk and not talk about Appium. Device Farm comes with out-of-the-box support for FWM202 now. So even if you have some minor versions of Appium that you need to add, those are all supported. Your friendly Device Farm CLI will switch it with the line, all the dependencies, including your WDA agents, your Chrome drivers for people familiar with the Appium ecosystem. It will do all of that for you just with that single line. So we covered the three things. Let me connect anywhere, let me customize it, and then let me run it from anywhere. Third, once you've done all of this, we see customers get even more creative. They have even more granular tests. So Device Farm also supports rooted Android devices. And this is primarily for use cases where if you look at the Android, this is because we are talking about Android. If you look at the Android documentation, there's a lot of documentation in there that says, hey, I can give you a deeper battery analysis, but it only works on a rooted device or in an emulator. That's one. And so that's one example on why someone would need rooted device. Other clever and nice way that I have seen customers really benefit, and this was a learning experience for me as well, is I've seen customers install 2 versions of the same app. So let's say your app package name is com.example1. And so I've seen customers have version V1 and V2 of the same package name signed by different stages. And then they install both those apps, because when you try to install the same package name on the device, it'll say, hey, I already have a package, I can't install it. But with rooted devices, you can override that. And then once it does that, it takes more metadata into consideration. So once you do that, they'll run one version of the app. Let's say that you say, OK, how long does my login screen take to come up? That's one. Then they'll run it on the second app. Oh, login for this one took X seconds more. And then they'll compare it. So you can have a comparative things having 2 versions of the same app on the same device. And that's only possible because rooted devices allow you to do that. So that's another example. The other metrics that we see is granular CPU consumption, something that Alex touched on his team uses when they do load metrics and other things. Rooted devices will give you more ability on that. They'll also give you deeper and more granular control on the file system. And these could be cases where you are taking a binary dump, taking a TCP dump perhaps on the device, saying how is it doing, what packets is it sending. And then you can take those files, analyze them, say, for example, in Wireshark, and just see that traffic's flowing. There's also advanced cases where we see customers use perhaps a Charles proxy, sort of intermediate man-in-the-middle proxy, where they're saying, well, the device is sending all the HTTP requests go to this proxy, and you're monitoring the traffic that's going in and going out. Rooted devices are not really needed for that use case, but you can have additional metrics logged on the device level in addition to what you could do just alone on Charles proxy, though that you can have a timeline where you're saying, oh, that request, HTTP request was sent at this timestamp. Here's what the device did before that. So you can know whether there's a problem in the network from the device to the Charles proxy to start with. So those are all the newer features we are launching. I highly suggest or recommend anyone who wants to get hands-on, there's a self-service workshop that you can try out. It is really nicely laid out with level 100, 200, 300. You can get an end-to-end test and app running. Don't have to have any app build or anything. So I would suggest trying that out. The workshop was today morning. Otherwise, I would have also suggested go and do the workshop. And that's it. That was the last thing. I really appreciate everyone coming out here today, taking time. Sam, Alex, and I will be outside after the session. If anyone wants to come in, chat, say hello, have any questions, happy to help you with those. Thank you.